Question 1A says, evaluate the integral, of 2 as the upper limit. I'll explain what each and every term means. So we have the 2 here. So this thing which is drawn like that is called the integral, meaning we are integrating. So to integrate, we use the symbol. It looks like an S, but it's a little bit curved. It's called the integral. So we are integrating this with the boundaries, which we call limits. So the up there is our upper limit, and the lower limit is -1. So the function that we are integrating is 2. The function we're integrating is 2 plus x plus x squared. Now, for some students that I teach mathematics right from the beginning, I don't start with integration, no. Most of the times I start with indices, because indices are actually a very good introductory topic for the topic of integration, or for the topic of calculus. Okay, so now what does it mean to integrate? What does it mean to integrate? Integration and differentiation are two immediate opposite components of calculus. So, first thing that I'll tell you, I have to take you back to indices. When you have y is equal to a constant 4, this thing here can be written as y is equal to 4x raised to power 0. Remember why they were telling us that any term or any number raised to power 0 is 1?
Yes.
That is a component. That's a principle I'm actually following here. So whenever you see a number just written, bear it in mind that that number has got a letter or has got a variable, and that variable is raised to power 0. Once you understand this point, you never go wrong. Number 2, if we have y is equal to 2x, what is the power on x?
The y is 0.
No. This one is equal to y is equal to 2x power 1. When the power is 1, we do not indicate it. When power is 1, we do not indicate it.
I'm confused. But wait, I have a question.
Yes.
So, you said for x to the power 0. Do you indicate, do you not indicate?
No, this part of second, we don't indicate it. This part of second, we don't indicate it.
Oh, okay.
We just write it as 4, because we understand that x raised to power 0 is 1, and when that 1 is multiplied with 4, it still gives us a what?
4.
It gives us a 4. So you need to understand that. Same applies here. When the power is 1, this power 1, we don't indicate it. They will just write 2x, that is all. Once you understand these two principles, the question that we have here will be very simple to solve. Okay. So now let's go. Now, how do you integrate this? Keep these numbers that we have, the +2 and the -2, keep them. We're going to have these brackets. Remember, what number is this? What number is there?
The number is 0.
So this can be written as 2x raised to power 0 plus, I'm just showing you for the sake of learning, but you don't have to show this in an exam. X raised to power 1
Okay.
plus x. So you see the order, So the power is 0,
Yes,
the power is 1, the power is 2. And now, these numbers that we have as a 2, we're going to write it outside, we put it on top. As a lower limit, we put it as -1 right at the bottom. Once you do this, to every power that we have on x, please add a 1.
So you said the power at what?
To every number that we have.
So I'm kind of asking.
What? Hello?
I can hear some.
So what I'm saying is that to every power that we have on x, we'll be adding a 1.
Oh.
And once we add that 1,
Okay.
yeah, once we add the 1, the same thing that we will have as a power, we'll come and have it as a denominator. What I mean is this.
Okay.
Let me use a different color now. So I'm going to say to this 0, I'll add the 1. To this one, I'll add the 1. To this 2, I'll also add the what? 1. Now, the same thing that I have it as powers, 0 plus 1, I will also have them as a denominator for the entire fraction. For the entire fraction, I will have that as a denominator. That is what we always. And once we have this, what are we going to have? We'll have 2x. What will be the power?
The power will be 1.
Over 1, right?
Over 1. Yes.
Plus. We don't change the sign, we keep maintaining the sum that we have. What do we have here? X raised to power
X squared.
Over
2.
2 plus x over, or x power
X over
x
cube.
power 3 over 3, right?
Yes.
2 and -1. Once we reach this point, our troubles are almost over. Now, what do we do? If the power is 1, remember at the beginning here, if the power is 1, do we indicate it?
No.
No. And if the denominator is 1, when you divide by 1, is it going to change? Is it going to change anything? No.
No.
It just remains like that. And here we have got x squared over 2, x squared over 2, plus x cubed over 3, and the limits that we have are a 2 and a -1. Please go through. Let me know where you don't understand.
So far, so good, sir.
Okay. And once we have this, what does it mean? We need to do what is called substitution. What are we substituting? We are substituting where there's x, we are putting a 2. So if we are to get this and take it there, we have a 2 as a number, right?
Yes.
Which is multiplying where there's x. What do we put?
We put 2.
So this is 2x plus. What do we have? It's a 2, right?
Yes.
Raised to power
Raised to power 2.
over
2.
Plus. What do we have?
We have 2 to the power 3.
2 to the power 3 over
3.
This we've closed. We have just used the what? The upper limit. Have we used the lower limit?
No.
The same thing will be done now using a lower limit, but except at the moment you change from the upper limit to the lower limit, you put a minus. So let's start substituting. Let's start substituting. What do we have? We're going to have 2 minus 1, right?
We have.
Are
Yes.
Have you seen what I'm doing?
Yes, sir.
We continue. So wherever there is x, where we're putting a 2, this time around we are putting a negative 1. Meaning, in regardless of what is there, for as long as the limits are given, you keep substituting. In all totality, doesn't change. It does not change. So let's compute. What do we have here? We have a 4, right?
Yes.
We have a 4 plus, what do we have here?
We have
a 2,
well.
right? Not a 2.
No.
It's a 2.
It's a 2.
Yes. Carry 2 times 2, then we divide by 2.
That's what I didn't do.
So I want you to solve like a mathematician. Plus 2 raised to power 3 gives us 8. Now, because 8 cannot be reduced when you divide by 3, we'll keep it that way. Are you understanding?
Okay. Yes.
Is it making sense?
Yes, it is.
Okay. We do now, we put a minus, we do the same thing. What do we have here? Negative 2?
We have
Negative 2. Right?
yes.
And what do we have here?
Negative 1.
No. It's actually half.
Yeah.
The negative is being multiplied how many times? 2
Twice.
times. It becomes positive. So on top, negative 1 times negative 1 will give us 2 or give us a 1, then it divided by 2. Remember, the power is only 4 where there's x. So this 2 is not being raised to power 2. Are you lost?
Yes.
So here, Mercy, we have, let me go back. We have, we have this thing which is squared. Negative 1 times negative 1, what do we have?
Negative 1 times negative 1, we have positive 1.
Positive 1, yes. So once we have a positive 1, it must be divided by 2. This 2 here. This 2 here is the one I've written at the bottom. Meaning whatever you find on top, divide by 2, and this is what I've done. Yeah. We come here. Negative 1 is being multiplied 3 times. When you multiply a negative number 3 times, the answer becomes negative. So if you have a calculator, you can verify that. Negative 1 times negative 1 times negative 1, it must give you negative 1 as the answer. Can you verify?
Yes.
You okay?
It is. Mm,
Okay. So, divided by what?
divided by 3.
Divided by. Okay, we can now do everything. So here it's actually 2 times 4. What are you getting?
2 times or 2 plus 1.
Oh, yeah. Uh-huh. 2 plus 2 plus 2 plus 4.
6.
We have a 6, right? So from here we go back here. We'll have a 6 plus 8 over 3. Do you agree?
Yes, sir.
The overall sign is minus. Open bracket. We have a negative 2. Can we compute this? Can we compute this part of a fraction? Can we compute this part of a fraction?
No.
Yes.
Yeah.
Mm,
How?
yes. We look for a common denominator. What is the common denominator here?
6.
First, we get a plus. See? We put it here. This is our plus. Our common denominator is a 6. How many times can a 3 go into a 6? How many times can a 2 go into a 6? 3.
3 times
3 times 1
3.
is 3. What sign is there?
Negative.
How many times can a 3 go into a 6?
2 times.
The 2. And then we close. The same thing we're going to do here. We find a common denominator, which is a 3. 1 into 3, 3.
3.
3 times 6,
18.
minus 3 into 3,
1.
1. 1 times 8,
8.
8. So this is what we have obtained from the first bracket. The only bad part about this is that there are fractions. Minus 2 plus, see, what do we have on top here? 2 different signs. We subtract, get a sign from the bigger number. It's a 1, right?
We have, yes,
1 over 6.
6.
We again here we make a common denominator, but here we can subtract. When we subtract, what do we get? 10
We get 10.
over 10 over 3. Minus, here we can just do a quick one. We can do a quick one. It's a 6. 1 into 6.
6.
6 times negative 2. Negative 2,
Negative
12, right?
12. Yes.
And 6 into 6,
1.
1 times 1, 1.
1.
So what do we have on top here? What do we have on top?
Negative 11.
So now negative.
Positive 11.
No, it's negative. It's negative. We have a bigger number which is negative.
Okay.
So if that is the case, so we're going to have negative and the negative. These signs are following each other. What do we have?
Positive.
Positive 11 over 6. Another fraction. So that's the bad part of this. We just deal with fractions and fractions and fractions and the fractions. So secondly, we're going to have our common denominator, which is 6. 3 into 6, 2. 2 times 10, 20.
20.
Plus 6 into 6, 1. 1 times 11.
Is 11.
So what will be the final answer?
31.
It will be 31 over 6. Yeah. So the only challenge you have is there are only fractions. Fractions, 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 and the fractions.
Sir, I have a question.
Mm-hmm.
Which part of calculus deals with that one for lim, then 80, shan?
Really?
The LIM, and then, Kaya, how to explain?
Really? Do you do that part of
And then,
calculus?
and then H, that's the R and 0.
R and 0.
H, and then R, and then 0.
Oh, no. Are you doing ADMA?
That's what we did on Saturday lesson.
No. Calculus, you guys don't do differentiation and integration of exponent C, of linear. You don't do integration by first principle. You don't do limit C. Those things are not there.
Oh,
No, they're not there. I'll send you the syllabus.
okay.
It's not lean, actually, it's limit. It's written like L I. I think this is what you mean. Maybe X here approaches 0, something like this.
Yes.
No, no, no. You don't do limits, you. You don't. No, you don't. You don't. Yeah. So are you okay with what you have done?
Yes, I am, sir.
Yeah. Okay. You've written.
No?
Please write. Oh, now you needed to go back to the original, or maybe you'll have to replay the video.
I'll replay.
I'll replay. You will replay, and I'll also send you the answer.
Okay.
Mhm. Okay. We go to the second one. Go to the second one. The second one is a bit easier. I don't know. I'm getting an echo. The second one is a bit easier. It's saying find the equation of the normal. This one is not integration. Here we use differentiation. So because you asked only to do with the integration today, I'm sure this part of differentiation we can skip it and reserve it for another day. Is that okay?
Yes, sir.
So that we don't combine theories. Yeah. Okay. The second one is this one now, which is very simple. Each time you see a limit having a 0, each time you see a limit having a 0, just know that the question is very useless. It is very useless in a way that I will show you. It is very useless in the way I will actually show you. However, you still have to do the integration. And when you integrate, we'll still have the limit. Now, because you have now understood the principle, I will not go through step by step. I will skip certain basic principles, right? So,
Okay.
right from here, what is the power? 2.
The power is
2.
2, yes.
So from here, we're going to add the 1. We'll have the power, which is 3. Meaning, here we're going to write x raised to power 3 over 3. Hoping you know where these values are coming from.
Yes, sir.
Mhm. and then the sign is minus. What do we have here? What is the power? The power is 1.
0.
No. The power is 1 because x is there.
Oh, yes.
So when you add 1 plus 1, what will be the power?
2.
So it's going to be 2x raised to power 2 over 2.
2.
Plus, it is at this point where we have 3x raised to power 0.
Okay.
Now, so when you add that, it's going to be 3x power 1. And when the power is 1, we don't write it. Therefore, we just do it like that. With a limit 1, with a limit 0. It's okay?
Yes, sir.
Now, then we substitute with a 1 throughout. Where there's x, we put a 1. Where there's x, we put a 1. So we're going to have 1 raised to power 3 over 3 minus, have you seen that these two values can actually cancel out?
Yes, sir.
So we are only remaining with x raised to power 2 plus 3 raised to power 1. 3 multiplied by 1, not raised to power. 3 multiplied by 1. We are done with our first substitution. Is it okay?
Yes.
The second one will do the same thing. 0 raised to power 3 over 3 minus 0 raised to power 2 over, no, there's no over because it's actually reduced. So it's just 0 raised to power 2 and then minus 3 multiplied by 0. We close and then we close. Have you seen that in each and everything we have on the right hand side? It's 0, 0, 0, 0. So this part will give
Yes,
us
sir.
a 0. This part will give us a 0. And this part will also give us a 0. So the basic principle is that if you have a limit, a lower limit, which is 0, meaning we are just dealing with the first one, the second one will just give us a 0. All together will just be minus 0, which is very simple. Because in your calculations, if 0 is involved, just know that the final answer will be 0. You get it? Do you get it?
Yeah.
So what do we have here?
Yes, sir.
What do we have here?
3.
1 over 3, right?
Yes.
So 1 over 3 minus, what do we have here? Oh, here it's actually a 1. What do you have here?
We have
A 1.
2. I mean 1. Yeah.
Plus, what do we have here?
We have 3. So you said 3.
Yeah, I say 3. So all this, we are subtracting a 0. Don't you think 0 should just be ignored? Zero should just be ignored because even if you subtract, you add a 0, it doesn't change anything. Okay, just be ignored. We come here. What answer do we have?
The answer is negative 2.
So we'll have 1 over 3 minus 2. A 0 has been ignored. We find the common denominator. Our common denominator is a 3, right? And 3 into 3? Three into 3 is a 1, ka?
Yes.
Okay. And minus 1 into 3?
1 into 3 is 3.
And then 3
2
times
is 1.
2? No. 1 into 3 is 3. It's 3. Then 3 times 2.
Is 6.
And what do we have as the answer?
We have negative 5 over 3.
5 over 3. As our final answer.
So I have a question.
Please ask.
I'm kindly asking if you can repeat.
Repeat where?
Okay, let me just ask this. Let me just ask this. So when you're dealing with 0 for the denominators, you're just going to put 0 everywhere.
Denominator, what do you mean?
Like the way you did on the other side, sir, dealing with 0.
Each time you are multiplying or you are dividing with a 0, the answer you get is a 0. For as long as 0 is not a denominator. But for as long as 0 is the numerator dividing by any number or whatever number, you multiply by 0 or 0 raised to power anything, all these answers will give you 0.
Okay.
So therefore, that is how that came to be the answer. You're good? You're good?
Yes, sir.
Okay.
Yes, sir.
Then we can, time is up, so we can end the thing and join again for the next 2 questions.